Okay, said the recording has started. So welcome everybody. Thank you for joining us today for the AIAA Los Angeles Las Vegas section educators meeting as a K-12. Let me see. Because our K-12 chair, RP she is not here. Let me see. Let me try to invite her again. Let's see. Let's see. If it show up, then we will ask her to say a few words because she has to teach recently. So sometimes she got busy, but she has been very important behind the scene, and we have been working closely together. Let me, if she shows up, we'll ask her to say a few words to welcome. But if not, then I also say hello, welcome on her behalf for you all. So AIAA, as you know, is a professional organization, but we emphasize the STEM education because we have many very inspiring professionals and educator. And we have, very importantly, we have high school student membership that is free. And we also have university students membership. And the educator membership is free. So if you're an educator, please join us. It's free, and you got a lot of benefit, connection, and resources. Um, so we have folks here in person, but a lot more people online, especially we have a group of students, 20 plus students from France, and they are going to have 5 presentations, a very exciting project led by, you can see here online, Mr. Mikhail Akila. I call him Mike Alpha. I'm Kilo Lima. This is the pilot code. So he will have a wonderful presentation with the student, and he will introduce the project and guide the student to make a presentation. And you will see the student very, very exciting student engineer. They are actually in universities, but their project very inspiring for the K-12 as well. So just try to say a few words. Also at the end, for people attending in person here, we actually there is Service Academy Day event this afternoon starting at 1 p.m. Led by our Congressman Ted Lieu. And it is very exciting. And I think he has been the United States Congress whip since 2018, and I think I think actually the Democrat leader, working with now the Mr. Jeffries in the Congress. So he highly support the service people and the service family and education. So you're welcome to stay. If you are here or you are online, then you can still come here in the afternoon or for the later part of this program to join us. And before that, I will introduce the Dr. Wallace because he nicely provided this Da Vinci School for us. So I'll ask him to say a few words and introduce the robotic team. And then we'll have Mr. Mike Alpha, Mr. Aquila, for their side of presentation from France. This is actually truly international and cross-continental. But before that, there's actually very important thing I want to do because here we have a very important person is Mr. Dennis Lin, and he actually gave a presentation to help our young professionals, but I haven't been able to present him our appreciation. So today I brought it here. So, and he's also going to help us for the college students. So we want to really show our gratitude. So here, in case everybody cannot see, this is our appreciation certificate. So thank you so much, Dennis. Appreciate. Thank you. Yes. And now Dr. Steve Wallace, and as I mentioned earlier, he actually provided this nice facility for our meeting here. And I just discussed with him, and we can continue to do meetings here. And this, you will hear from him. This is a really wonderful school, a very exciting program. And there's wish people to know more about this. So without further ado, let me bring Dr. Wallace here. But first, present him our appreciation here. Thank you so much. Thank you.
Thank you very much. We're really grateful that AIAA is here. Happy to be hosting you. My name is Steve, and I'm one of the founders of this school. We are 14 years old this year. We started back in 2009, not in this building. We moved into this building it was about 8 years ago now. This is a former Northrop Grumman building that the Weisburn School District, together with the Da Vinci Schools, recreated this campus. And so in this building, there are actually 3 high schools that have about 550 students in each one. Each floor is its own different high school. And here on the second floor, Da Vinci Science High School, each high school has a number of career pathways. And here at Da Vinci Science High School, we have 3 career pathways: mechanical engineering, civil engineering, and biomedical engineering. One of the great successes of our program is our robotics team, FRC Team 4201, the Vitruvian bots, and I'm really excited to bring them up and introduce them. In fact, you guys can come on up and set up your presentation for us. And while they're doing that, I'll share. So I've been the principal at Da Vinci Science for the last 13 years. This year, I'm an executive director supporting all the schools in the organization. There's some folders on your tables there. For those of you that are here, you're welcome to take those with you. And at the end of today, at the end of the meeting here, if you're interested, please feel free to just walk around the floor. Our robotics team is here like they are pretty much every weekend, and they love having visitors and guests. So they'd love to tell you more about what they're doing and the competition they're engaged in this year. So I just invite you to enjoy the space. And again, we're very happy that you're here and would love to host you anytime you're looking for a place. We'd love to be your regular meeting place if you'd like one. It's an honor to have you here, and we're really grateful for you. Thank you. And with that, I'll hand it off to the real stars, who are our students and mentors.
Hi, everyone. Good morning. My name is Haley Duncan. I am the vice captain of Team 4201, the Vitruvian Bots. My role on the team is I've taken more of a logistical standpoint this year. I have experience in computer-aided design, manufacturing, and assembly, but I wanted to take on scheduling and keeping track of our team and our robot progress over the course of the season, since we are trying to be a little bit more ambitious this year. So making sure that everybody is on the same page is really important to be sure that we have the most efficient team that we can have and everybody is not stressed out and everybody is having fun.
Hey guys, my name is Gabby and I'm a senior in high school. I'm the captain of 4201, and last year my focus was on business and logistical things. So I focused on the financial aspects of our team, but I do still have some technical skills. But going into this year, I'm focusing more on the logistical aspects regarding big events and team management within our team. So yeah.
Hello, I'm Joy Hara. I was actually on the team in high school. I'm now a mentor for the program. I'm a current call student at the University of Southern California, studying mechanical engineering and systems engineering. Really excited to be here. I actually do a little bit on the collegiate side for this organization, so happy to be here.
So as we mentioned earlier, we are Team 4201. We have about 80 students and around 15 members on our team, and we are a part of the first organization, First Robotics, which has allowed us a lot of opportunities for our students and for our team. This picture on your right is one of the documentaries we've been featured in. It's on Disney Plus, titled More Than Robots. If you enjoy this presentation, I highly recommend going to watch that because it just highlights the first experience even more. As Steve mentioned, we are part of Da Vinci Schools, and in the center is a picture of our team from one of our previous competitions last year. We, as a team, try and focus on a lot of outreach into our community, especially focused on STEAM. Here's another picture of us in the center, and you can see on your right, once again, the pop-up is a little blocked, but we outreach into our community. That's actually one of the FLL, First Lego League, which is like a little sister program to First Robotics. It's like the step before actually moving into robotics. We hosted a competition for them on this campus, and we really aim to inspire community members to get into STEAM. And no problem. And going off of that, first is our program that we are a part of. The mission of FIRST is to inspire young people to be in science and technology. The FIRST acronym stands for inspiration and recognition of science and technology. And our team really has tried to put an emphasis on this over the years. I know I have especially been affected because being on this team has just solidified the fact that I want to pursue a STEAM career. I'm looking to pursue mechanical engineering, and this team has provided a lot of the skills that will prepare me for the field that I want to pursue.
Oh, just before we go on, we kind of wanted to share our experiences with being in first. So from my experience, going from like a business and logistical side and moving on to more like roboty and like logistical big impact things, I've learned a lot of skills and how it works to be in the industry. And I think it's really prepared me for my experience in college or university, or if I happen to be in a job in a local area around here. Definitely this team has prepared me for that experience.
Okay, moving on, our mission statement of our team is to serve as a STEAM hub where our community members are inspired to learn, grow, and collaborate with each other. And even though this is a newer mission statement of ours, our team has kept this quality throughout the years since we've been founded back in 2011. We've been opening our resources to our community so that everybody is able to have the same experiences that our school is able to allow us and gain those opportunities that everybody may not have. And so here's in the center a picture of our summer Lego camp, which we'll be talking later a little bit more on. We have another picture seeing one of our founding robots actually earlier on, and another picture of teams coming in to use our resources on a practice field that we have downstairs. And now I will be handing the presentation on to Gabby.
Anyway, another aspect of our team in regards to outreach is how we advertise to other people in our local community and how we connect with students from K to 12 and inspire them to join FIRST programs. And this is through STEAM Expos. So sorry about that. One aspect of our STEAM Expos are our robot demonstrations. This allows us to visit elementary schools and present our robot. And this is probably one of my favorite experiences when I get to connect with other kids, just because like I feel like the first initial thought when like kids see a robot is like, can we drive it? And obviously we have those resources for students to allow that experience to occur. So we let students drive our robot and pick up the balls and take it into our robot. So that's one aspect that really introduces students into STEM. In addition to that, we've impacted over 3,000 students in our local community. In addition, our robot demonstrations are shown here. We've been to Wise Spring schools, schools in Los Angeles, and Redondo Beach. Another thing is our STEM activities. Regarding our robot, being able to introduce STEM in other manners is one of our specialties. So from doing this, we've allowed activities to occur. One example of this is actually our hackathons, which are experiences where we go to our local middle school and present STEM activities. And it was really awesome for me to see this because in middle school, I didn't really know I had these opportunities until I went to like my local hackathon where our team was doing this. And then having that experience and moving on to high school and being a part of this team and being able to give back to my community has been something that's really inspired me to not only pursue a career in STEM, but also give back to my community and help students and provide resources for them. And then do you want to talk about the first minority dialogue?
Yeah, so another part of our outreach that we do is we try and connect with our students on a personal level because not everything is about robots here on our team. So we try and represent everybody's culture or their backgrounds equally. Moving on to the first dialogue that we had was uplifting Black voices over quarantine. It was a very rough time for the Black community, and being able to connect with my teammates on a way that was more than robots, that was more than just talking about, oh, have you assembled? Have you done this task yet? It was on a deeper level. How are you feeling during this time? How can we support you? It was really a refresher in a very dark or hard time for the Black community.
In addition to this, our minority dialogues have allowed a space for students on our team, in our school community, and in our first community to express their thoughts on different various topics. So another one of our dialogues that we hosted is the Stop the Hate dialogue, where we allowed people from without our team to share their experiences from being in STEM and the hard times during quarantine. So overall, our dialogues have a sum of over 300 students attended from the first and our school community. In addition to this, some topics that we've discussed are the model minority, microaggressions, and then moving on, one big part of that is our Women in STEM panels, which was collaborated with Raytheon Technologies. So from doing this, I was able to communicate with other women in STEM from local industries like here, like Raytheon, Northrop Grumman, and the Aerospace Academy to come and answer questions about their career, their experiences, and we've had over 50 students attend these.
So one of our other flagship programs is we love the expos, we love the activities, and getting that like one chance to like showcase. You know, you should be in STEAM, like you should explore this area. But we also know that it's important that sometimes students need continuous encouragement. So we do a few things to make sure that students have the resources to learn. So one of those is we love to mentor. So the elementary, middle school groups of this program use Lego robotics. So we mentor at over 35 teams and at 15 tournaments to reach thousands of students and teach them how to program, how to build in with Lego robots, and ultimately encourage them that they are able to pursue STEM careers. Anybody can. We also volunteer at the tournaments to make sure that the students have a positive experience and get good feedback when they're giving their presentations or completing their robot runs. Another flagship program of the school is we've been running a Lego Robotics summer camp for 8 years. We have impacted thousands of students through this 2-week activity where we basically take the Lego season and compress it into a week and show the students how to build, how to program, how to work as a team, how to and most of these students actually move on to be a part of our program or a part of the other high school programs. And it's been really amazing to see how students come back year after year and just get more and more excited as they go through the different levels and the different activities. So that's it for how we've showcased in our community how students can get involved and be a part of STEAM. If you have any questions, please let us know.
Thank you. What a wonderful team. We'll stay connected and wish to hear your update next time. Thank
So it's not.
Around March 18th, we have a facility that is capable of housing these teams, and we're very fortunate to be able to affect our community. Yes, in the gym right there. Weekend of March 18th. Thank you. Oh, great.
Wonderful. Thank you, Karen. Any more questions for? Thank you. Thank you. Thank you. Thank you so much.
We're only going to 2 regional competitions, and then if we qualify, and win like the impact award, which is like an outreach award kind of, and then or a robot like based award, then we can go to championships. So we'll see. Thank you.
Thank you.
Thank you. Thank you so much. Wonderful. Okay. So this is just to show that this Da Vinci School student is doing wonderful job. They actually have other teams in science and engineering. So this just to show how they are doing. So now we turned it to our friends in France, and so we had Mr. Mike Alpha. That's the pilot code name, and
Yes.
he's going to make some introduction to himself and to the team of student he's coaching, and then he will guide the student to start the presentation. So, okay, go ahead.
Thanks, Kilo Lima. I like very much their green T-shirt. You see. Sorry for my English from Marrakesh. Even if I was born to the White House, yes, because Casablanca, Morocco, Casablanca is White House when we translate. Thank you, dear Ken Kilo Lima. Yes, this pilot surname, for the opportunity to present the work conducted by the student engineering of Estaca, College School of Aeronautics and Automotive Engineering, located in Paris suburb, for the e-car group, electric car and its Shilowsky device, and for the 4 other groups in Talence, in suburb of Bordeaux, our national reserve of high quality fuel. Let me introduce myself, former of the DGA, General Direction of Armament, Ministry of Defense, military aeronautical engineer, now retired former scientific journalist at La Dépêche du Midi. I can finally focus on the development of some of my concepts, which will be presented to you. Kenneth Louis, Mr. Kilo Lima, editor-in-chief of AIAA Los Angeles, Las Vegas branch, has allowed me to publish some of my articles in his famous newsletter. I thank him very sincerely for this great spirit of cooperation. Ladies and gentlemen of Estaca, you have the floor.
Thank you so much. So let me start the first presentation here. Let's see.
The plasma propulsion. Yes, that's good.
So go ahead.
Okay. Hello, everyone. Can you hear me?
Yes.
Okay, right. So we are really proud with my team to be here today to present you our project. Um, Let me introduce myself really briefly. I am Lucas Bilan, project manager of the project on the plasma and thermal reactor. And I let my friends introduce themselves.
So my name is Nicolas Fab, and I will be the second person to present to you today what we have done. And I don't think the rest of the team really want to talk right now because they a bit shy. But we work with Camille Solacrou, Pierre Dorin, and Robin Rostocker, and so we're really excited to present you what we have done.
Right, thank you, Nicolas. So our objective is to research a new way to make space travels faster and easier. Our idea is to couple two reactors to make a travel from a lunar base to Mars in the hope of future colonization. The first reactor is the thermal reactor, a model invented by Michel Aguilar here and patented also in the United States. And this reactor is really interesting because it could save fuel during the travel between 30 and 35% in terms of reduction in specific consumption. Moreover, we want to use the high technology of variable specific impulse magnetoplasma rocket, and we will call it for further the VASIM-R. The objective is to boost the capacities of VASIM-R with those of the thermal reactor, which could be integrated into it or also serve as a complementary impulse so that a trip between the moon and Mars could be achieved in 30 days. Now I let Nicolas talk to you about the thermal reactor and the plasmic propulsion.
Yeah, so about the thermal reactor, it is an engine designed specially to provide the amphicycle recommended by the DARPA for its good return by using valves permanently in motion at low speed, around 2000 rounds per minute. In fact, this type of cycle is described by an isochoric combustion, meaning at constant volume, and outperforms the conventionally used Brighton cycle. The thermoreactor can, however, perform either in isochoric or isobaric mode in order to take advantage of each cycle, depending the use. Now to plasma propulsion, the first thing to know about it is that it revolves around the idea that producing and accelerating a heated plasma at more than 10 million kelvins and ejecting it at 10 to 100 kilometers per second velocity can create a strong thrust force. Moreover, it is supposed to deliver power between 10 kilowatts and 100 megawatts using either solar or nuclear energy sources. Finally, the main idea behind the coupling of these two technologies is to take off using the thermoreactors and then turn on the VASIMR, which are the plasma engines, to travel to Mars from the moon using both, so that the plasma will be preheated by the thermoreactors before entering the VASIMR. Thanks for listening.
Yes, it is.
Mike Alpha, is this one?
Yeah,
The
yes,
second one.
that's right. That's right.
Okay, go ahead.
Okay, Elisa, we don't hear you.
Yes, I'm here. Do you hear me?
Yes.
Okay, so hello everyone. My name is Elisa Bianchini and I'm here with Suzelle Levaux. And the three other persons of the group are Thomas Cochard, Kylian Grémontpont, and Robin Larcher. We are today going to introduce to you the lunar propulsion and tides. So thanks to the tides generated by the moon, it is possible to transport about 15 passengers free of charge over 60 kilometers in a capsule traveling at more than 300 kilometers per hour without any felt effects or any impacts on the environment. So with natural and free energy and no external energy necessary. So you can now show the video if you have the link. I don't know if Michel give it to you.
Yes, you did give me the link. 1 second. The only thing is I didn't expect that you will play it here, but let me do it here. Okay. Okay. The video. Yeah, you did send me. Let me.
If you can't show the video, it's not very important.
Okay. Let me see. Page.
Okay, don't worry. You can't show the video. Next presentation, perhaps.
Okay, so I will still get the video ready, but let me first for the next chart. So next one is TAD.
Yes, exact.
Hello, can you hear us?
Yes.
Okay, so we have
Yes.
the takeoff assist device group. So here is Thibaut Conan, Leo Bocobza, Baptiste Richard, and Enzo Fago. And we're going to talk to you about our takeoff assist device, which is an upgrade from the reverse thrust mechanism that is now installed on your today aircrafts. It's based on some work done by NASA about a stationary ejector, which redirects the flow surrounding an engine into the output of the engine to add a lot more thrust. So we also have a video, but I can share it to you if I share my screen.
Oh, yes.
Yeah.
Yes, go ahead. If you show from your end, it will be faster.
Yes. I don't know if you can see my screen. It's a PowerPoint presentation.
Yes.
Okay. So I'm launching the video.
Could you start the video?
Yes.
Each
Yes,
aircraft
very
has its own takeoff speed. At
Do you have the
100%
sound of the
power,
video?
the engines consume
Yeah.
about 10%
Okay.
of the total fuel. On landing, some aircraft activate the reverse gear to travel less runway length to save brakes and tires. The principle of the reverse is to deploy flaps to redirect a large part of the thrust forward. These same flaps can also function as a booster, ejector principle, to increase thrust at takeoff. This device makes it possible to significantly reduce noise and takeoff time with a gain in consumption of at least 20%. As the aircraft climbs to cruising altitude, the flaps retract to regain the initial drag.
Okay, could you show your mechanisms?
Yeah, of course. It's Baptiste who is going to present
Okay,
it to you
Baptiste.
now.
Go.
Yeah. So now you can see the first version of our mechanism that we created with Katia. So in addition to the thrust augmentation, the takeoff assist device has another advantage. As you may know, the warm flow is from the engine is responsible for a major part of the noise. And with the takeoff assist device, the warm flow will be surrounded by a cold flow, which will significantly reduce the noise. Thanks for your attention. If you have some questions, don't hesitate to ask us at the end of the other presentation.
Very good. Thanks, Thierry. Next presentation, perhaps, and question after.
Yes, can you all hear me?
Yes.
All right. So can you see my screen right now? Can you see my screen or not?
Yes.
Yes,
We see.
So, we have my teammates, which are Julien Boulet, Pierre Cotela, Louis Bourset, Romain Mianet, and Lucas Fruchet, and myself, Florian Chedon. I'm going to talk about the wing in ground effect project, which consists in using the ground effect to reduce the fuel consumption of aircraft. So as we all know, a wing works with a depression at the top and a suppression at the bottom of the wing. And this suppression creates a cushion of air under the airfoil. And basically, this allows the wing to increase its lift.
Yeah, excuse me. You are showing the slide, right? Could you show again? Okay.
Yeah, right now, slide. And by increasing the lift, we can decrease the angle of attack, and this way decrease the drag and the fuel consumption of the airplane. So basically, I'm going to show you a video of how it works, and then my colleague Julien will present you another video of how we are gonna train pilots to fly this airplane, basically. So I'm just gonna show you the video right now, which is gonna be right there.
Claire and Kataro could be living in a city or a remote area. Today, they need to reach a distant location, a 450-kilometer journey, not easily done by standard transportation. To get there in time, they make an instant booking for a capsule. A capsule chariot autonomously arrives to drive them to the nearby takeoff area, located at the outskirts of the city. At the gateway, their capsule is clipped to a wing for immediate takeoff. The capsule takes off vertically thanks to its revolutionary engine embedded in the wings. In a few minutes, they reach cruising altitude and cover the distance at a speed of 200 kilometers per hour, consuming only 15 liters of biofuel per hour. Claire and Kataro can relax, enjoy the scenery, and prepare their arrival, thanks to the autopilot and security features. Upon arrival at the intended destination, the capsule land at the gateway and trade the wing for a chariot to drive the last mile. Claire and Kataro make it to their destination in time, relaxed, ready, and satisfied.
So yeah, basically that was the video presenting the project itself, and now I'm going to let Julien talk to you about how it works and how we're going to train pilots for it. So go ahead, Julien.
Hello, everybody. So, as you can have seen on the video, the vehicle here uses the wind in ground effects to fly over an highway. So, the interest is that by flying at very close to the ground, you have an aerodynamic interaction between the ground and the wing of our aircraft that reduces the, um, uh, the the drag, which is a force that pulls your plane or your aircraft back. So these effects allows you to well, fly faster with and by using less fuel, and uh, this is the interest of this winning ground effects. Then in this plane should be able to fly over the highway, and in case of well, meeting a bridge or tunnel, it can also be able to fly upper and over the bridge or the mountain. So we have to think about a way to make it possible to fly at low altitude, then occasionally go to upper altitude. So the way of piloting such a vehicle is not as different as flying a plane. So any airline pilot could be able with a day formation to actually piloting it. Thank you.
Claire and Katara wish to book a capsule to reach their final destination. They are able to do so, as Claire has already attended a pilot captain training. This training took place on the ground via a capsule simulator. She was able to learn the full operation of the capsule, like when passing a driver's license. Claire got her license and is now captain on board. She is also able to communicate by radio to Andrew, the station manager on the ground. Indeed, the capsule is tracked by ground stations at all times. Andrew is a drone pilot, and he connects to the capsule as soon as it takes off. He can remotely control the capsule if necessary. Katara can relax, but Claire remains in permanent contact with ground stations.
So if you have any further question, don't hesitate to ask after all the presentations, and
Yes.
That will be all for me. Thanks.
Thanks, sir. The last presentation, please.
Ok, alors.
You'll show your slide from your end, or you want me to show the slide?
I think we'll do it on our end, no problem.
Okay, so go ahead.
Yeah.
Did you share? You click the share
Yeah,
button.
it's coming, sorry.
Okay.
Thank you. So, can you see my screen?
Yes.
Okay. So, hello everyone. I'm Geoffroy Martel and I'm the team leader for the eCar and Shilowski device group. So we will present during this presentation the Shilowski device and the capsule we made for it. So the Shilowski device is a system that would fit in a bumper of the car and extend the battery life without any impact on the environment, just by using aerodynamics. So I will now show you the video and then we'll go deeper on the capsule and then the Shilowski device.
Energy density of a battery measures its efficiency. Lithium-ion batteries display a density of 250 watt-hours per kilogram. The two
The
forces
video
that
is not.
impact the
We are not
autonomy
seeing
of
the
a car
video.
are the rolling.
We don't see the video.
I don't have it on my end, so I can make a resume of the video if you don't see it on your end, because
you can you can share the whole screen. If you share,
Yeah,
click share,
I'll do this.
not just the
It
PowerPoint,
works also.
just the whole screen.
Yeah,
share
the
the
whole
screen.
screen, and now you should
Then you
see
can
it.
you should be able to show the video.
If my computer wants to share the whole screen, I hope, please.
We see a.
Yeah.
Then you
Can
need
you
to
see
move.
my whole screen?
I can see. Okay.
Yes, yes.
Yes.
It's
And
very small, but
with the sound, it's better.
Energy
And now can you
density
see
of a
the video?
battery measures its
Okay.
efficiency.
All right.
Lithium-ion batteries display a density of 250 watt-hours per kilogram. The two forces that impact the autonomy of a car are the rolling of the tires and its aerodynamics. To reduce these forces with a minimum of energy, the solution is to create an aerodynamic shield at the front of the vehicle using the Cholowski effect. The air that would otherwise hit the vehicle and slow it down is then deflected. A booster supplies the air to the bumper. This device, patented and issued by France in 2019, is currently being examined in the USA. By reducing these forces, this device aerodynamically increases the density of the battery from 250 to 370 watt-hours per kilogram, the autonomy from 400 to 600 kilometers, and reduces the power from 106 kilowatts to 55 kilowatts for a highway speed of 80 miles per hour.
Okay.
So now I will let you go present to you with more details the Cholowski device and the pod we designed for it.
So, hello everyone. So tell me when you see the presentation properly.
Yes.
It's okay.
Okay, so we are going to present to you the Cholowski e-car project that my colleague Geoffroy Martel just told you about. So we've been working on this project with 5 other students. So Geoffroy Martel, myself, Théo Joannick, Théo Montfort, Clément Gerbeau, who is also here with us to present to you this project, and Baptiste Billac. So the main idea behind this project is that we will create a pod on which we will use a new aerodynamic effect that is called the Cholowski effect. So this effect will allow us to reduce significantly the drag of the vehicle. So for that, we will just quickly explain what aerodynamic drag is, to be sure that everyone knows what it is. So because of the air viscosity, air particle will be forced to move along with the vehicle when it's moving. Basically, the speed of the air particles will be stuck with the vehicle when it's moving. So the main idea would be to increase the speed of the air particle at the surface of the vehicle to reduce drag. So for that, we decided that we could use the Cholowski effect. So you've probably never heard of the aerodynamic Cholowski effect. It is a derivative of another more known aerodynamic effect that you've probably heard of, that is called the quanta effect. Perhaps you have already done this experiment or seen it for yourself. Tried to take a pipe blowing air and put a little sphere in it, and you see that the little sphere is kept prisoner in the blown flow. So here we are using this aerodynamic property of a flow being stuck on a curved surface to keep a fast blown flow stuck on the surface of the pod. So just like you see on this little animation, we will use this principle to blow a fast flow on the surface of the vehicle in order to increase the speed of the air particles that are close to the surface. This will allow us to reduce the drag of the vehicle significantly. we are talking theoretically reducing up to nullifying the drag on the blown parts, which is very significant. So here on the vehicle that we are presenting to you, we are only blowing on the upper surface of the vehicle, and we are already reaching results up to 30% drag reduction, which is already really significant. So when it comes to the pod design, we have made it to be a two-place vehicle. We took dimensions that would be close to an already circulating vehicle in France that you have perhaps already seen or heard of, but it's not a problem if you have not. That is called the Renault Twizy, which is a small electric vehicle that is already in circulation in France. As you can see from the dimensions, it is small, but it is something that batteries capacity and also trying to reduce drag as much as possible forces you to go for, at least for the moment. And so we are with, as you can see on the parts at the front of the car, we have this space here, which is the part where we blow the air. And we have at the rear, we have the compressor of air, which is used to blow the air at a higher velocity. So we made, in order to make sure that we are gaining energy efficiency from this, a modelization of the energy that we could get from the batteries with the Shilowsky device.
So back to me. So as you can see, we did an Excel to just try to model the effect of the Shilowsky device on the mass of the batteries. So for this kind of vehicles, as you saw in the video, the two forces we try to limit are the drag force and the resistance of the wheels. So we can't affect the wheels, of course. So our goal is to reduce the drag force at the minimum. So to model drag reduction caused by the Shilowsky device, we introduce a coefficient called the Shilowsky coefficient, that we will multiply to the drag force. This coefficient is between 0 and 1, 1 indicating it does not affect the drag force, and 0 indicating we totally erase the drag force. So I don't know if you can see well the Excel, but we first did a test with entry values without the Shilowsky device at standard conditions, for example, 140 kilometers an hour of speed or 81 miles per hour, for an autonomy of 500 kilometers or 310 miles, a vehicle mass of 600 kilograms, and an energy density normal. We get a battery mass of 532 kilos, which is quite big. Then we use the Shilowsky effect, and we only touch at the Shilowsky coefficient right there, which goes from 1 to 0.7, so a 30% reduction of drag. And we can see that we already gain 100 kilos in battery mass, which means that we get an equivalent energy density of 308 watt hours per kilogram, which is more than the common lithium-ion batteries right now, and all of this due to aerodynamics. We also gain a weight of about 20% that we can either reuse and keep the same mass that at the origin, but prolong the autonomy of the battery, or we can gain this weight and use it to put other things in the capsule.
So we also need to make this a road vehicle. So I'll let my other colleague speak about the.
So our pod design doesn't enable our vehicle to move yet, so we need to add some wheels. So let me introduce you the cart we came up with. As the capsule is quite small, we couldn't put 4 wheels directly on it. we may have some space for 3 of them, but that's without counting the size of the batteries. So we decided to create this card to put our 4 wheels and some of the batteries. Here's the first sketch of this card. On one hand, it increases the turning radius of the vehicle. On the other hand, it doesn't break the usual aesthetics of a car. However, the weight of the vehicle will be increased, and this will also create more surfaces in contact with the air, meaning more friction and therefore more drag. Unfortunately, we are still working on it, so we can't show you more pictures than that. The most important thing is that the design will remain very aerodynamic, so as not to lose the gains of the Shilowsky effect. The height will be low enough, and we will surely cover the wheels again to avoid having more drag.
So to conclude with this presentation, so as you've seen, so for now, if I'm just go back to this slide because the animation looks nice. Currently we are in the final modelization process of evaluating and reaching the maximum drag reduction possible. So for now, we are at around 30% drag reduction, but we are aiming to reduce it even further, at least to up 50% drag reduction, which would allow to further increase the autonomy of the vehicle. And then once we have finished the modelization process, we will create a test vehicle that we will be able to use in a wind tunnel in order to verify through experimentation the calculations and the modelization. And we will then reach the final part of this project. So if you have any question, do not hesitate. We are here to answer your questions.
Thanks. Okay, Kilo Lima. That's all.
Oh, thank you. This is a wonderful presentation. And just to let everybody know, actually, we have been posting a couple newsletter articles in our AIAA Los Angeles Las Vegas section newsletter. So if you are not on our mailing list of the newsletter, let me know, and we can add you into our mailing list so you can receive our newsletter. So you're while we're waiting, if there's people here has more questions, I have a question. So you are saying this is you are going to have a experiment. You are going to make a Chelosky car. Is that right?
Yes, in order to confirm the calculation and the modelization, we will make at least a reduced model size to test in a wind tunnel. And after that, we will aim to build a real one. This will probably not be done this year, but this will be the goal for next year, or the student that will go after us for this project in the next year.
Next year.
Yeah.
So you're talking next year. So the wind tunnel, you are using some wind tunnel at school or somebody else wind tunnel, or you build your own wind tunnel?
So here we have a wind tunnel in our school. Depending on whether or not some of the equipment will be available or not at the time, we will be able to use the wind tunnel of our school, or we will try to reach companies on the area around our school to see if they will let us use their wind tunnel.
That's a good project. You know, if you can use your school or use the companies, that's a good collaboration with school or the company. That's good. So are you going to make a real size car or kind of smaller one? A real size, a big one, or is a small
For
car?
the wind tunnel, it would be a smaller one because most of the wind tunnels we have near us aren't big enough for this car, of course. So first it will be a small scale, and then maybe not us. maybe all the students that will take the project after us will try to make a real size one. It will be hard. I must say it will be hard, but I think they can do it.
So what's the material? Are you going to use 3D printing or send it somewhere to make it, or you are going to build it with your hand?
For the reduced model, we will use 3D printing. We
Okay.
have a lot of different student associations in our school that already have the necessary material to and equipment to do 3D printing. So if we are going to do a reduced model, we will do it via 3D printing.
Okay,
And
that's good.
for a real size model, this will first require to have a much more advanced definition of the different parts of the vehicle that will need to be created. And then we will be able to see how we want to create it.
Ken,
That's good.
we offer this your next car.
That's good. Yeah, so keep us posted. It's very interesting. We want to know more about your progress. Of course, also other project as well. But this one seems to be, you will be able to make something, so people can see. The other one is more on the concept side. So this is very interesting. Any question?
The most challenging part of working together as a team in process?
So
What's the most? Yeah.
could you repeat the question? We've not heard everything due to connection issues.
Can you hear me okay?
Yes.
Okay. What was your most challenging part of working together as a team during the design process? And what was the most challenging part of your design?
I would say working as a team has not been much of a problem for this project, at least. In our school, we are used to work on a lot of projects each year. So we've already have a lot of methodology to how to organize ourselves in projects. So this, at least for this project, was not much of a problem. The biggest challenge, I would say, for this project was to manage to create something that would both be working in the aerodynamic side and that would also match a certain aesthetic criteria, because if you create something that is meant to be a vehicle that does not look good, it might be a complete failure, even if it's really good on the aerodynamic. So this was a big part of the making something functional but aesthetic as well. On top of the fact that the Shilowsky effect is very unknown, and that finding the documentation precise would be hard because there is simply a lot less.
Tu peux dire aussi que on a déjà fait des simulations qui prouvent
Ouais, mais c'est pas la question.
l'effet. Mais ça
C'est pas
fait
la
rien.
question qu'il posait.
Certes, mais tu peux le dire quand même
S'il pose la question, on leur dira.
Ouais.
Thank you.
Would that answer your question?
Yes, thank you.
Any more question? Well, hopefully, your team, when you build it, you can demo, of course, from your side, but someday you can come here to Los Angeles, bring your car.
We do hope. We do hope one day we could do this.
Yeah,
It'd be
actually,
nice.
I don't know if you follow our events. I mentioned to Mr. Ackler, the Mike Alpha. We had the event last year that's called the 1910 Air Show, Air Meet in Los Angeles. That's the first international air show in United States. And there were a couple people from France. They flew their balloon, the airplane in Los Angeles, and it was very exciting. So a lot of people, very well-known people, you know their name. They were actually very young or kid, teenager or college student at that time. They attended the air show and they were very exciting. And traditionally, you know, there are a lot of collaboration and development with and from France. So you are doing very good jobs. Keep the good work. So stay in touch.
Thank you, Ken.
Thank you.
Thank you.
I just want to say good job, guys. We are proud of you and keep up with the good job and the adventures. I represent a nonprofit here, and we try to help kids in these areas. And I'm very proud that kids like you are into this because a lot of kids are in the wrong way. So congratulations.
Yeah,
Bye.
Thanks to you.
Thank you. Yeah, so thank you, everyone. That's great presentation, all five of them. It's really wonderful. And thank Mike Alpha.
Thank you, sir. Next
Yeah.
time.
Thank you. Okay, so that's done with our presentation for today. So for people who stay, welcome to stay. We'll have a very kind of short discussion, you know, about what people's interest and what you need and what you might um, uh, benefit from AIAA. For example, I can first say from my end, from our end, is that AIAA has the main group is a body of professionals. So we have people working like Dennis here, and he has been working in aerospace company as now as individual. He also work in government, and we also have Karen, you know, for educators, and and also Dr. Wallace as educator, and we have you know, people from nonprofit organization. Um, so actually the purpose of this educator meeting, we also welcome students, but basically we want to know what you need, you know, and what we can provide for you. For example, what we have been doing very well is that if you have classroom, you know, then we can outreach. We have engineers, you name it. We have people from Boeing, Lockheed, Raytheon, NASA, JPL, whatever you name it. You know, we can call for volunteer or Dennis can also go there just to inspire students, give a pep talk, a presentation. This is we want to and the other thing we also do outreach that we can do, and we also have been trying to do some demo. For example, Dennis is helping us like virtual reality, and we have Raspberry Pi, and of course you hear the student they're doing robot. We have people also doing robot, and the real one, you know, on Mars, and also the local ones. So like Raspberry Pi, you know, is also related to the software operating system, cybersecurity, and we have people working. For example, our former K-12 chair, she is actually working in relativity space. And as you know, relativity space, they are using 3D printing to build rocket, the real one. She is now in Florida launching the 3D printed rocket. So that's our strength. You know, our people working on real things and our educations, nonprofit, and we can kind of provide some kind of demo or ideas or people, but we want to know that what we can do for you, and we have a range of people. For example, Mike Alpha is a great is a former France Air Force pilot and engineer journalist. So you can see he's guiding this wonderful project, and we also have very top level. For example, our executive director, Mr. Dan Dumbacher, he actually just gave a talk in December here on DCXA rocket, which was 20 years ahead of SpaceX and Blue Origin. He was the director of the DCX project, the vertical landing, launch vertical landing, and can move horizontally. So that's actually the grandfather the SpaceX rocket. So honestly speaking, SpaceX cannot claim they invented the rocket. It's actually our executive director in NASA. So we have this kind of people, and we have connection to, say, NASA administrator and many different companies. For example, Green Shotwell, Bill Gerstenmaier in SpaceX, Elon Musk. But these are people generally they don't show up every day. If any special need, they will show up in our major conferences. So another strength we have is the conference. We have publications, journals, or Aerospace America. If you join the educator membership for free, you'll get free Aerospace America. And then you got to be able to chat online with all the experts. They call it engage. So there are a lot of benefit for educator and students. But other than that, we want to know for your function, there's something we can do for you or work with you. So maybe if you want to say something, you can raise your hand, or maybe I will start from here.
Yeah, we have a nonprofit. My name is Wilbur Owens, and we formed a nonprofit about 2 to 3 years ago. And the nonprofit's goal is to encourage aerospace development. And we're based at an airport locally, very close to your 1910 event in Compton, California. It's a non-towered airport. We have several hangars, and what we're involved in is amateur rocketry, one of the concepts. So we go all the way from the K to K-12, from kindergarten all the way up to high school. And we use Estes rockets, and we have an area in Los Angeles called Santa Fe Dam. We launched the small rockets up to an altitude of about 1,000 feet. Also, we're part of a group out in the Mojave Desert that's called the Mojave Test Area. And we have an actual waiver where we can launch a rocket up to 100,000 feet. So we start with the excitement with the small kids, and we have a program for high school as well as for the college students. One of the things that we worked on small liquid rockets. Those are very difficult. And because of the safety requirements, we can't do much at the airport. So we work out at the desert. Also, we have another program where we work with small aircraft. So we have a program where we take them apart, we make modifications, and we put them back together. So our whole focus is on aerospace, aircraft. The other thing that we offer, which is something that typically is not available, we're at the airport, we have several hangars, and the hangars are a substitute to say if you can't do the work in your garage as a kid, you're free to come to the airport and work in a safe hangar. So we have all kinds of experiments for kids, and we allow them to play in a very safe environment. So it's sort of like back to where some of your basic engineers, their philosophy would be to get the best engineer, you need to have hands-on training. You need to have an opportunity to learn the theory, but you need to be able to go apply that theory. So we're creating that lab. So we're working with VSTOL, we're working with electric motors, and I tell the kids, we're able to do anything that you can imagine. And we come up with quite a few things. And we have a facility out in the desert to where it's safe. So as a nonprofit, we have the flexibility where we're not constrained by the academic environment with schools. So we're a little bit more freer to do things. So we do it in a format of a club. So we came here today because we do have a shortage. We have good people that can work with us, but we need a few more engineers to maybe where we can expand what we do. My training is an aerospace engineer. I have worked with rockets and boosters, but I like to get some more engineers. Like one of the areas that we're really weak in is electrical control. So we came here today to maybe offer ourselves to say if there are some other people that like to participate, we have a great safe environment to do that. So that's pretty much who we are. The name of the organization is called Atmospheric Vehicle. Yeah. Yeah. So what we specialize in anything that flies, whether it's going to be from ground zero up to whatever altitude. We have participated with some of the local universities like USC. They come out to the MTA to test their solid rockets. and some of them come out to test out liquid rockets. That's just a component of it. But for kids, they're inspired, like with flying airplanes. So we have several airplanes that we fly as a result of donations, and they're very simple, and we allow them to work on it with proper supervision. So, like I said, today was our first opportunity to come out and look for engineers.
Okay, that.
No, that's
Oh,
that's
you
the
work together. Oh,
yeah,
very good.
Yeah, with any organization, you need an engineer, but you got to have somebody financial so you don't get in trouble with the
Financial, very important.
Thank
This, no problem. This is what we want. We want people to network and help each other. You know, you express your need, and we or some people, we also provide a network. That's actually AIAA doing very well. But it's not just one meeting or something. It's kind of long term. You meet different people. Actually, you mentioned Mojave Desert. We actually have a member. She is running STEM academy, but also a research lab in Mojave. It's like a simulator. You know, adults, kids can dress like astronaut. You know, those kind of Mars simulator, and of course they also do like space medicine type of research. So we are working with her. She lives in LA, but you know her you know activity. You cannot say company. Her nonprofit academy is Mojave. And personally, I have been to Compton Airport a couple of times, especially before pandemic. And I can tell we have two person. One is we have a member. He's actually I don't think he owned a hangar, but he built his own aircraft. I don't know if you heard of him, Dr. Williams, Dr.
Yeah, Ron Williams.
Ron Williams.
Yeah,
Yeah,
Ron
he was
Williams.
AIAA.
He's a big builder in some of the amateur aircraft.
He's
there
also
at
our
the field.
member.
Yes, we know him.
Yeah, and we have another gentleman. He said he just moved there. Is Dave Nordling.
Dave is Dave actually is president of the Reaction Research Society.
Yeah.
And that's a famous group where Elon Musk's propulsion engineer Tom Mueller actually did a lot of work to develop the Merlin engines, and they would go out. He started out in the desert. He started as a kid with Estes rockets. So we kind of look at that as a guide because he was inspired with these small rockets, and he decided to keep tinkering, and he came up with something even better. So that's basically where we are, because some kids don't have access to the information, so we want to create that for them.
Yeah. I know Compton is very good area. Actually, I've been there before pandemic multiple times. I even saw in a museum
Tomorrow's Aeronautical,
and there's very nice cat. You know, very nice, very friendly cat. I remember, and I actually talked to them. I was thinking about doing some AIAA meeting there as well. I look at aircraft, runway, and Dr. Williams actually was about to, because he gave a talk to us about the aircraft he built based on the World War I model, and we actually organized a tour. He wanted to show the actual aircraft, but pandemic hit, so we canceled. He didn't want to run the risk. So I'm trying to talk to him if he want to do it again. After seems to be safer now. And Dave actually will be, he show up regularly to our events. You know, not today, but you know, some other event, he just show up in person. And he actually, I actually have a plan to stop by to see him and Dr. Williams too. And we can kind of connect each other, and I can.
Yeah, I think you'd be surprised, and I think you'd be very excited because the thing.
And I also even remember there's your handler has some simulators,
yeah, within the museum they have simulators.
Yeah. So you for your organization you own or rent a couple of hangars. That's what you do.
We have 4 hangars. We have a very large hangar where we keep a biplane in.
I see.
And then we have another hangar dedicated to the amateur rocketry. And then we have another hangar where we took some students from Cal State Long Beach and we worked on a vertical takeoff and landing vehicle. So to level with you, all these are things that I always wanted to do as a kid. And now we have the resources and we're just running wild to have fun doing that. So any technical thing that we want to do, I tell the kids, if you have an idea, come and let's put it together and play with it. So one of the projects that we had a aircraft designed by Burt Rutan, which is called a Very Easy. And we wanted to make that into an e-racer. So we took the wings off and we're going to make it into a race car. So whatever any student would have an idea that they want to do, we want to be there to be able to do it.
Yeah. So what I can think right away is that there are multiple levels, but number one is a thing we can do. If you are interested, we can do a meeting or event there. You can come here like this place, or we can go to your place and you can make a presentation or like a site tour about your facility. And with this, people will see, you see what happened. For example, today, we have 20-something people online. Well, I just chatted with Dr. Wallace. These days, if online people will just stay home. But you have people show here. But actually, there are several thousand of people that saw the like a bio or information, so they knew that what's going on, who is doing what, even though they didn't show up in the event. But I chatted with our member, they knew what's going on, and some professor changed their course material, or K-12 teacher, they changed because of events, but they didn't show up in that specific event. So we also have social media. So the easiest way is to participate. For example, you give a talk in our event, or you can even at your handler that we go to your place. Yeah, and we can have a tour or something. And there were people.
We definitely would like to do it. But one of the things that I would like to emphasize more than anything else, there's academia, and we choose not to be academia.
I understand.
What we choose to be 100% is the lab. We want to have the tools. We have the tools. We only want to be the lab. Academia is a major part of it, but that's already taken care of, like with a school like this. But the biggest limitation has been the lab, to where you can get things done, which would be the desert, Santa Fe Dam area, where you can have an area to launch the rocket, Compton Airport, where you can fly your vehicle.
That's right. That's right. I can tell you, actually, AIAA is, I think is really the right organization, because I told people, actually, I just chatted last week with people. Oh, it was a young professional, because he was an engineer in Boeing. He's an engineer in Boeing, but he said he was interested because he's in the pilot school. Okay, I said that's no problem, because AIAA actually is the best combination, because we are not a GA group, but we do have a lot of pilots. Dr. William himself is also instructor, and we have Dr. Daniel Raymer. He is the top well, people say he's the father of B-21, but he was very modest. But anyway, he has a textbook on conceptual aircraft design. He's viewed very highly, and his engineering, he's a PhD, but he's a pilot. Then you talk about electric aircraft or vertical landing. Do you know the company Ampere? Ampere. It was actually a commercial company right next to Hawthorne Airport, and there are a couple of our members there. And Dr. Susan Yin, she's a pilot. She's our AIAA fellow. She's a scientist, engineer, and she's a flight instructor. So AIAA has a lot of people very excited about aviation. Yes, maybe 80% they were engineer, but I can tell they are at least 20%. They're engineer and the pilot. And I will even have a speaker from Aerospace Corporation. He owned a Cessna. So our group is very special in a sense. We are not just like a pilot. You have many pilots group here. They talk about the flying something, but we are a different group. So the academic thing is part of it, but we also cover different things.
Another thing I want to share, it's good timing. Da Vinci is researching right now, starting an aviation program here. We've had a couple meetings down with the Torrance Airport at the Western Museum of Flight that opened up with the CEO of Sling Flight Academy at Torrance, and with a gentleman named Dan Mixon, who started a nonprofit called Giving Kids Wings, teaches kids to fly. And there's a lot of momentum behind aviation programs, especially for students in 12th who are interested in, learning not only about being a pilot, but folks at the at LAX, talk about the number of non-pilot aviation related careers that are available. So this school being across the street from the LA Air Force Base and a few blocks away from one of the world's largest airports, we feel like it's a great opportunity for kids to go straight into good paying jobs. So one of the things I've been tasked with this year is to research the possibility of and get started some sort of aviation training program. So would certainly like to stay in communication with anybody here who's interested in talking more about that.
Oh, that's awesome. That's exactly what we like. Yeah, we know Dan. Dan has been doing outreach for years, and it's been so long. He bought an airplane, and it's been very difficult for him, but he's been hanging in there, and they've made a lot of progress.
You know, so I think he's a great example of, he's a credentialed teacher. He loves students, and he's a professional pilot for SkyWest, but that just pays the bills so that he can do what he really loves, which is to teach kids to fly. And so we've got students here who have their pilot's licenses and they don't have their driver's licenses yet. So their mom has to drive them to the airport and then they can fly the plane. But it's pretty exciting what's happening. We have 16-year-olds who are you're doing their solo flights. So he starts them with gliders, and they do a lot of even the ground exercises. And we've got a whole class set of yokes and rudders and the pedals and everything that kids can learn here. So we had that going pre-pandemic. We're getting it started up again, and would love to talk with you more about that.
Very good, very good.
Yeah, this is what we do with people network, and either we provide the networking opportunity. So like what your conversation here, and help each other and let people know and this is recorded and more people will know your activity. And we do event here, and a lot of people show interest or your school, Da Vinci, even French people, they got excited. Then now you come to, actually, I have been actually thinking about what AIAA's role, because there are several museum handlers. Actually, Torrance, we do you know Mike Simonera, the president of the Torrance Museum? Yeah, he's the president of the Museum of Fly in Torrance. He's our member. He just published. Cindy, I met Cindy. Yeah. Yeah. We are connected to them, and we actually have events there, or some of their people with us. We actually have a kind of semi-tour, because they have a YF-23 model there, and so they have I forgot a pilot. I think is Marty. I think he was a former test pilot for YF-23, so he gave a tour over there. But actually, I visited several handlers from or the airport or museum, also the Santa Monica Museum, and also the one in Long Beach. Long Beach also, I mentioned this, I've been to Long Beach. Actually, I actually just called the Long Beach airport yesterday, because they used to have a company called Ross Aviation, and I was thinking to do some event. They have a room there. Now they call Atlantic, but they no longer do it anymore. And hello, welcome. Please join us. Hi. Oh, Dr. Wanda. Yeah, thank you. Hi. Thank you so much for hosting.
Well, I think Dr. Wallace is the one who gets all the credit. Welcome. We're honored that you're here. Thank you for your important work, and it's good to see everyone.
Yeah.
Thank you, sir.
Thank you. Yeah, we were just wondering this, what a wonderful school, and there are a lot of great activities and education resources. So we are engaging a conversation for nonprofit group and AIAA. We have a lot of engineers, scientists, and how could we work together? And we also providing, like today, a platform so people can meet each other. So for example, today we even have people from France, that's join us, and of course all the other people from other state, and of course locally as well. So we are trying to provide the network and well, I mean, this is for educators, but we also try to provide our strength. We have a lot of engineers, different aerospace company, and or professors or student, see if something we can offer. Of course, one thing important, we want to bring the community together. to know each other, help each other. For example, they have a launch facility for rocket in Compton, and that was mentioned also somebody in Torrance, something people can work together, find the resources best for teaching or learning, this kind of thing.
CEO who said, none of us is as smart as all of us. So thank you for being the connective tissue for all this important work. Yeah.
AIAA is very honored to fit in this role, and that's what we want to do. And it's strength. We have people across all different places, and we are. I have always got this kind of question: are we competing with Elon Musk? Are we competing with somebody? But no, we are a nonprofit, professional-based organization, and even though we don't compete with Elon Musk, but our people actually. I don't want to use that words, but we were ahead of them by 20 years. For example, I just mentioned our executive director, Mr. Dan Barker in NASA. In the 90s, the NASA team he led built the first reusable rocket in NASA called DCX XA, 20 years ahead of SpaceX. But nobody knew. People are saying, Elon Musk invented, there's a Blue Origin, Jeff Bezos. No, it is for executive and his former team. But we don't own the product. We don't build a rocket to compete with Elon Musk. We don't have our own astronaut or satellite, but we have members, we have astronauts, and we have people launching satellite every week, launching rocket. That's who we are. So it's a very interesting organization. And another thing I want to mention is we have a very long history. You mentioned about Boeing, right? We'll just mention about this in 1910. There's an air show in Dominican Hills. The first international air show in the United States was in Los Angeles. It's 1910, and there was William Boeing and Jim Doolittle in that air show. And a couple of famous people, and when they were very young, and the air show inspired them. What I wanted to say was around that time, the Wright brothers formed an organization on aviation, and Robert Goddard also formed an organization on rocketry around that time. And those two organizations merged into AIAA in 1962. So
working together in the different programs we're starting. I know you have to head downstairs for the next event, but when I saw you, I wanted to make sure they got to see you. And it's thanks to Dr. Wonder that we're connecting with so many other networks as well.
Here. And for your work in building this school and building Da Vinci schools. And thank you for bringing this wonderful organization, because all of us together can do some really good work. And people online, right? But I can't see them online. Yeah. Yeah. Anyway, thank you, Steve. Thank you.
Thank you so much, London. Thank you. Thank you. Yeah. Thank you. Thank you. Yeah. This is what I want to express. And actually, just around here, Aerospace Corporation, Raytheon, Millennium Space System. Our former chapter chair is actually I think he's now the VP. And we have a couple of members, they actually work in Millennium. So this is our strength. If you need somebody to work with you, we can try to reach out to them, but they may not be kind of immediately say, oh, I'll go to your organization, something like that. So generally, the best way is to participate in our activity, and then sometimes they will show up, and you can invite them. We will mention to them, but they already see the information, especially if we set up your presentation or something like that. And that's how we kind of met Dave, Mr. Nolan. Yeah, because we knew he's our member, but he's busy. But some event he got interested, he will show up. We have other people who launch rocket or doing, as I said, like electro. You said the electro, but we have people working on those things. And there's a company, Torrance, called Moog. They are building the parts. We have engineer from that company too, aerospace. And so we are an interesting organization. We don't build something, we don't own a spacecraft, we don't own something like that, but we have very interesting people. I can tell you, I just mentioned before we engage in this conversation, we have people that are engineer, textbook writer, and author, but they are also pilot instructor. It's just amazing. Of course, we have educators, and I want to address this university thing because it mentioned not just you have this academic done, you are looking for more laboratory, but I still have to emphasize that you're working with USC, right? We have 4 university student branches: UCLA, Cal State Long Beach, and UNLV. So we actually have a student mini conference. If you register in our event, I'll check with the emails. I'll send you those information.
Okay, very
So
good.
I understand you probably don't need academic, but we
Well,
are.
the academic is important, I guess. Let's see, how can I describe it? And I'll be very clear. AIAA is fantastic. You're like the glue that holds us together.
That's right. We want to
So
continue.
what I was finding is one of the things that we were lacking.
Yes.
We never had a place to actually go experiment on the things.
Okay.
You have a wind tunnel at your college, but one of the things I found is that some of the engineers that came to work with us there at Cal State Long Beach, they had never worked with tools before. So we had to teach them how to work with the various wrenches and tools to work on things.
That's interesting because you mentioned Cal State Long Beach, right? We just have a outreach to Cal State Long Beach. They actually has a very nice rocket
They have
building.
a rocket club.
Rocket club, a very nice facility to hands-on build the rockets. But I think they work with some amateur rocket group to launch
There are two amateur rocket groups. There's FAR, Friends of Amateur Rocket.
We have a member in
And
FAR.
then we have the Reaction Research
That's right.
Society, which has a facility called the MTA, the Mojave Test Area. They're co-located, and they have waivers with the FAA based on being allowed to launch a rocket up to a certain altitude. So various colleges participate with that. So one of the things, some of the colleges that have proper funding, they actually have the labs and facilities so far to build and work on the rockets. But one of the areas that we really are lacking is you don't have anything for the younger kids to come and play. So if they could come and work on the rockets at an earlier age, they would be super sharper engineers in school. So one of the things, and I would just be very clear with it, one of the famous German engineers, Werner von Braun, one of the things that he wanted to advocate to make a good engineer, you need to have hands-on. So it's been my experience that these guys are very sharp academic. We have a great academic system to train them in the fundamentals. But what we lack is the vocational aptitude to actually physically put the product together.
I can tell you one thing is that we have a lot of people, engineers on rocket. That's my personal experience. It's just at the same time, yes, if you are looking for professional to participate, one thing I want to say, especially in the launch business, a lot of these people, they have security clearance. So most of the time I realize that they are not allowed to tell people what they are doing or going out randomly to participate in something because their company or government would not allow them to do that. So even a few times I was trying to look for a speaker, I found out who was doing what, and their company was not very happy about it. Even though we are nonprofit.
One of the ways that we work with that is this. They have ITAR, they have security requirements where they can't participate. But we can be very clear, the technology that we're involved in is very primitive. The rockets themselves are unguided. It's no feedback loop for guidance. It's an open loop, meaning that you have a propulsion system, you have aerodynamic, or some aerodynamic, but not aerodynamic active control. It's ballistic. So basically, we've worked it where you don't need to get to a security level of new proprietary information. It's just basics. And that's what we work with.
Yeah, I know it very well. And that's why I want to say in the very beginning, because that part actually is not what AIAA can handle for their company employer thing. So what we can do mostly for networking, providing information. And I can tell you, I know those engineers, their company know much better how to handle this. So for us, we are not uh, in a position to work this kind of ITAR thing with their company and to give the person to you. But what we can do best is to connect, hey, know this person, and if you both interest and that you can work this out with their company, the detail, what they are willing to do. And but we generally have this kind of discussion. For example, we have even come up, got a suggestion from our member, why don't you build a satellite? And get the state-of-the-art technology from each of the company, because we have member we satellite from different company like Courtney or our former director. He was in Boeing Phantom Works. You just get all the advanced technology from each of the company. The idea is very good, right? It doesn't work that way because they all sign the legal document with the company. They are not going to tell you or you apply any of their Boeing advanced secret technology. They're not going. And how do you define is okay technology or not okay? It's beyond AIAA. That's their company issue. But what we can do is we let them know and let you know, and we provide this opportunity to know each other, and or I can even introduce each other. But those kind of technology, which technology they deem okay to help or not okay to help. So honestly speaking, when you mentioned about AIAA, I know that some people kind of view AIAA might be more academic. The reason is because we have lots of people. Dennis will know this very well. He used to work in the government and company. I mean, they cannot disclose. They cannot really do much about this. So, and the most of the people who can do public things with showing our video, education will be people from university. So you think AIAA is a lot of university? No, but actually our majority people are actually working in company like Dennis. But those people, they are hidden. And for example, you see every launch, Vandenberg, Florida, every place, a lot of our members, they're hidden. You don't even know them. And then they are not allowed to tell you what they are doing. Even within AIAA, they are not, unless they went to like a conference, present their paper, that, oh, he's doing this. Generally, they are only after they feel comfortable. And I can even, we have member retired. He told me that he signed document for 20 years after retirement. He cannot say anything about his project. Yeah, for that.
Which is fine, which is fine. And that's the thing I would emphasize. That's not a problem. We're not looking to advance technology. We're only looking to build a base.
I understand.
And that's what, so basically for the ITAR requirements, the security requirements, nothing reaches any particular security level. So
I understand. I will merely try to explain that you're referring to academic. I just explain why people have this impression, because academic is more free. But AIAA, that's why AIAA is really interesting, because we have a lot of people working kind of behind the scene. There is, kind of possibility or opportunity there, but you have to do it kind of connect to the right person and do it properly. We have people from Air Force and F-35. I can tell you there's people, but you see, you have to kind of connect it properly. And so I've been trying to work this out with our leaders, something like that.
This is probably a very, very good time to do it. Just listen to everybody talking right here. I am from that industry. I've spent 20 years at Northrop Grumman building space products as an engineer. I've worked with NASA and I've worked with the U.S. military. I am retired from there, so I have my own consulting company. So I do understand the separation between the two, right? I do a lot of outreach as well for schools, universities, or other organizations, maybe as yourselves as well, as kind of generating interest in the aerospace industry, number one. Number two is really to show them how we really do things in the industry that's not necessarily really taught at the academic level. So I've noticed that a lot of students that come out really understand the theory, but they don't really understand the real world of how things are actually done. So they're really starting from scratch again. And so that's really my main focus when I go out and give these talks with Ken or other organizations, is to really let them know and show them how we build space products, whether it's satellites or anything else, how we build them, how we test them, how we launch them, So I have familiarity through all of those operations, right? Integration and test and launch, from project management to ordnance to alignments to just plain mechanical integration to logistics, all the way to launch site operations. And so that's my outreach, is to really let people know what we do and how we do it. And so I understand that separation between the two, because I do consulting on the side as well. And so that's consulting versus outreach are two separate things. And consulting is, where you have to abide by all these ITAR rules and, corporate your clientele, what they really want for privacy as well. So I definitely understand that. And I have a lot of friends who are retirees in specific subjects as well that I can potentially, reach out to, and maybe they would like to, help and join your organization as well too. Because, as I said, I've got a lot of contacts and a lot of people that used to work for me in these organizations are experts in alignments, ordnance, environmental testing, everything that runs the gamut. So I'm sure some of them, right, yeah, absolutely. Like I said, a lot of them are retired too, so they'll probably be willing to donate some of their time here and there.
Thank you. Yeah, to people that Dennis is really the best. Knows all the rules, and then he retired, and now he has the freedom to do some more things. So he's really please connect with. That's what we want to do. Provide you the people, and know where are the the needs, where the needs are, and where the talents are, where the people can do something or people cannot do something. That's what we want to do. We will keep trying. And so if any question, but I think the action number one is that we can do something in your place, or you can speak in your place, or you can come to our event to speak. We can arrange that very quickly. And actually, I've been thinking to go back there, describe. I love those cats. I really love. It's really nice. They just came to me and sleep. Very very nice cat. So, Karen, do you want to say something? Do you have anything that we can?
Society of Manufacturing Engineers.
Great, good. Let me just kind of say we are working on a event. A panel events is the manufacturing and the supply chain, and Dennis will participate. I discussed with Dennis. Yeah. So we have a VP, from some company. That we have scientists with NASA. We're going to talk about supply chain technology and job opportunity. Those things.
Nice.
Emphasize those as well.
So our goal is the education to profession succession. So it's education and getting kids exposed as early as possible to introduction to engineering design, principles of engineering, digital electronics. I can't take any of the credit for all these great classes. I only introduced them here, and Steve took off with it. Okay. And what a difference it made in these students' education. Two of my kids went through Da Vinci, and they are successful now, and they got to try different things, new things. So in the South Bay, we have hundreds and hundreds of small companies, and we also have the big ones. So, and my goal is, like yours, is to bring us all together so we are all aware of what is available.
That's right. Yeah.
The conversation. If you don't know what's going on.
Yeah.
So
that's right.
I love what I do. I'm post-secondary specialist, El Camino College for over 16 years.
Okay, El Camino.
Developed a couple of different pathways: engineering technologist, engineering technician, engineering pathways.
Yeah. Or if you can give a talk or say something, in our activity, or we can go to your place. That get more people know that we can arrest. Let's do that. Actually, I can tell. Actually, I stopped by your college a couple of times. Yeah. I even know you have an observatory. I think astronomy group, and very nice meeting conference, like meeting room, something like that. So I've been working on it. And the other thing, education is, as I mentioned, we have student branches in 4 major universities. But I also noticed that a couple of times we have community student, college students come to us, and we actually have successful story. We have member that he was formerly our council member. He was from a community college, and then he transferred to USC, and then he worked with Boeing. Now he's working in Virgin Galactic. Yeah, so understand that community college may not have like a full blown like aerospace department or mechanical engineer like USC, but it's still exactly. That's right. That's right. That's right. Yeah, and actually we are going to participate. We actually focus on this makers things, but it is makers. We are going to the makers fair. Fair. Yeah. Yeah. Yeah, actually, what happened is because we kind of have to balance because AIAA, honestly speaking, everybody is a maker. They have to make rockets, whatever electronic thing, but it is a little bit different from those maker society. uh, they generally have much bigger or like company Boeing, facility much nicer, and the maker society like you were talking about is more for everyone. So in a sense, we have to see what is the best combination. I've been trying to look at. Sometimes there's some makers event, but our member may not be interested because they kind of used to kind of full-blown facility. Why do they have to do something come more less equipped, facility? But they understand it's to inspire people. So we also have the intermediate like universities. So that's I try to find out. But we have been doing a couple hands-on like Raspberry Pi things and. Something you can do, you can build. That's actually part of the reason we do this Dr. Williams building aircraft event. And our student branch university, they have the design, build, and fly. That's AIAA project. Every year they have a competition. They do hands-on. They do build, and they also have people build the drones. University. But I honestly speaking, I have to say that because those university has more resources, so they can afford, and advisor, professor, they can guide them. They can found and guide exactly technology-wise as their program to do it. So that's has been the other way been doing that 50 years, something like that, those kind of thing, or CubeSat or something like that. But I agree with you, is outside those university, people still want to learn and get exposed. That's what Dennis can help a lot too. Of course, he's also helping our university people, but inside the university, generally, they have their existing professor, existing grant to support those students. So typically they have much more leisure resources to do. And sometimes those projects, that's why we do this March University student event, because their projects sometimes inspire outside groups. And whether or not other group can work with them or find their money, that really depends on where you talk to, or like what you did, you work with the university. Like we USC group, liquid propulsion laboratory, and they were our students, and they broke the student altitude record a few years ago. Yeah. RPL, yeah. That's right. Not the rocket, yes. Yeah, because they has a rocket laboratory. Is also have a LPL. There's RPL. There's LPL. Yeah, and you kind of they have. Sometimes I have to say this. Dennis from USC. Yeah, at USC, for example, relativity space was also founded by USC. Yeah, that's why I want to say we know all their professors. Like Ronnie, Professor Ron, he's going to give a talk in April. Yeah, so his schedule didn't work out for his former professor and Professor Irwin, Daniel Irwin, Professor Mike Grantman. It's just it's hard to kind of compare because USC has a very top program, aerospace or mechanical engineering program. like all star faculty member, and they generally connect to all the major universities. So their Rocket Lab got the sponsorship from many major companies, but other universities would not. UCLA probably got something, but not other universities. That's the difficult part. And for us, we connect to those major distinguished universities or professors, but we also want to help some other, you know, and it's a lot of time we realize actually our students in those major universities, they already got a lot of help. They got a lot of exposure already. And the company lucky point, they love to go to those universities to have job fairs. And so most of them, they got the top offers. But we also, sometimes we learn that the community college student, they come to us, they want to learn community. I just talked to I don't remember if it's probably he was from El Camino. Okay, I met him from another event. I forgot. No, student. And he said he was also interested in transport, space program, something like that. So I immediately mentioned the member of mentioned the transfer and had successful story. So this is something that we can play some roles. Then we can kind of show some, our student can kind of share what a successful story, what they've been working on, and they participate in our university student branch event. You can get to learn what they are doing and their approach to advance in aerospace. So that's another part of strengths of AIAA. So there are ways to tap into. Now today you meet Dennis, and hopefully next time we can get our Millennium Space folks right next door to join us. I was hoping because they were just right next door. We used to have meeting in their company, but when Boeing acquired them, they don't allow us to be there. So what I am trying to do is trying to help people identify what you need, and I'm trying to set up some kind of meeting or something so you can meet with people from LA Air Force Base, and then you can check out with them if they have outreach opportunity or for Dennis, for you, or they can support or partner with you or go with you, something like that's what we are trying to help out as community, head up a community. Yeah. And there are kind of couple more resources. It's hard to explain, but I can tell the most important part is people. We have a lot of people. Yeah. Yeah. If it, yeah. Ah. Yeah. Actually, we've been to the elementary school, have exhibition, and we went to middle school, high schools. And personally, I have been the judge for science fairs. At two science fair judges. Next week, I'm going to one of them as judge. And our people generally we call a couple judges, but sometimes they got busy. But that we did that sometimes. A lot of time our member also engage in mentor activity, but it is more their personal because otherwise nonprofit, we are not running the mentoring business. We are not running the after school or something like that. But our member generally through this kind of networking or like a personal interaction, hey, there's opportunities. For example, I met a student when I judged the science fair a few years ago, and I told some of our member working in Raytheon nearby or Boeing, and they told, hey, this student is great, good project. Are you interested? And I get agreement from both sides and provide the contact. They chat. It's not the other way, got any money or something in between, but I just try to connect. So there's something work out. And that student actually, I don't know where, he did a wonderful job. He not only get the first place in science fair, I think he got into MIT, a very good program. But you see, for us, we do this contrary to what people think. We do have a lot of people, but we are at the same time we are not running broker or school. But most of the time it's a networking, and we help you to connect to the right person, and that person can become personal or group mentor on his or her own will or time. But it's not we we have a school that we send you the teacher to do this. It doesn't work that way. Some people, that's why we are trying to explain, but we do have a lot of people who are willing to do that. And whatever they do afterwards, after discussion, that's actually between the student, teacher, and them. And another, just to wrap up the discussion, as an example of the success, one of the best way to benefit from AIAA is, again, people networking. We have a member, he's a Hollywood film director. He made the film. There's another story, there was a film on the planetary defense, Dark Mission, they call X-ray Hunter. That's an IMAX film. But that's a different successful story. Now he's working with major aerospace company at NASA. But this director, he make a film, DVD on aerospace artist. Then he want to show it on International Space Station. Then he tried to contact NASA, it never worked. So I tried to help him as a group, and he volunteered with us. He come to speak in our event. We have field screening, and finally he met a former NASA retired Air Force colonel, and the colonel actually also worked for NASA to train astronauts. So he happened to train the astronaut for going to space station. So you know the story, they work out 3 months, they came, the film was shown on space station. And without anybody knowing, they just chit chat and network and they work out. It's actually very powerful, but it's not that, or other way, assign this pilot to help you. No, it's not like that. But we provide the opportunity to meet the right person. And we can even tell him, urge him, please help, this is for coming. But for us, we are not trying to kind of specifically try to do some, but we can do our best to some extent. But a lot of things still depends on your effort, connection to. But the more you participate, the more you get your name known. Or for example, Dennis spoke with us a couple times. Now people are requesting his video, his slide. Everybody know him, and so that's kind of the way it works. Or we go to some schools and the people know, oh, this school is doing a good job, something like that, and they will. Actually, the Da Vinci School, they host us here. We actually get some contact, inquiry about the school. So that's kind of how it works. For us, I can kind of say yes, please exchange information, but that's probably the most we can do. We're not trying to say, hey, please go to help this school or no. It's difficult for us to do that, but we provide the connections. All right, thank you so much. Appreciate it. Great meeting. Nice meeting you. Thank you. Yeah. Oh, okay. I see. Let me first turn off the recording.